Okay, students, today we're going to talk about identifying the conics given an equation. As it says here, one of the best ways is to rearrange the terms and complete the square. And then you can see if it's set up as one of the earlier ones that we've dealt with here. Okay, so we'll go ahead. It says state whether the graph equation is a parabola, a circle, an ellipse, or a hyperbola. Well, the one that separates, there's two things that separate out easily to tell. The two quickest ones to be able to tell would be the parabola and the hyperbola. Okay, remember, a circle is a perfect ellipse. So those two are the two toughest to identify. Hyperbola, remember, it has to have a minus either in front of the x squared or the y squared. There it is right there. It's in front of the y squared, the minus. Ones, they have to be opposite signs. So if that's plus, then that's minus. If that's the case, it's a hyperbola. So just from looking at that, automatically a hyperbola. I didn't have to do this completing the square at all. Done. Okay, I'm just telling you the shortcuts. Okay, you can do that and check it, but that's a shortcut. If it's a parabola, okay, remember if it's a parabola, it's y equals x squared, or it's x equals a y squared plus, extra stuff. So there's going to be one where there's only one of them is x squared or y squared, and the other is x or y to the first power. Okay, so if you have that set up, then automatic parabola. Okay, either y equals x squared plus extra stuff or x equals y squared plus extra. Boom, that's a parabola. When you have a degree 1 and a degree 2. For one term, it's degree 2. For x's, for example, is degree 2 and y is degree 1, or x is degree 1 and y is degree 2. Then it's a parabola, done deal. That's the two quickest without having to do anything to look at and be able to identify. The reason that the circle is tougher is because an ellipse is because they're both pluses in between. Okay. Now you might think, oh, well, I remember on the ellipse it's set equal to 1. Okay. Well, the key is on a circle, remember it's x minus h quantity squared plus y minus k quantity squared equals r squared. So I could have a number over there, okay, and divide, and I think, oh, it's an ellipse, I'm going to divide by whatever that number is on both terms. So here's how you can tell whether it's a circle or not when you're thinking about doing that, or an ellipse from this situation. If when I divide by the r squared, whatever that number happens to be, okay, if I get the exact same number, so when I have some number here and I have some number here, remember I have to cancel it down, simplify it with the r squared and the number. If when I'm done, these two numbers are the same, okay, whatever they happen to be when I'm canceling these down right here, if these two with the denominator, if those two denominators now are the same, that is a circle. If one is like 6 and one is 4, that's automatically a ellipse. Okay, so if the numerators after simplifying, if the numerators are the same, if the denominators are the same after simplifying, then it's a circle. If the denominators are different, then it's an ellipse. Okay, that's how I would go about remembering any of these. Write an equation in standard form, state whether the graph the equation is that, then graph it. Okay, so I see x squared, and for the y's, there's only a y. Automatic parabola. There's no y squared there to make it an ellipse, circle, or hyperbola. It's automatically a parabola. Y equals x squared. Since y equals x squared, it opens up or down. Since the x squared coefficient is positive 4, it opens up. Okay, you're still gonna you can still go ahead and work on completing the square and all that kind of stuff to put it in vertex form and all that and graph it, but I'm just telling you right away. Here, notice I have the x squared and the y squareds, so it's a plus for both of them. Okay, so this is plus for both. Okay, I'm going to have to check, complete the square, and then divide whatever this number is over here. Like I said, both sides cancel with the numerator. If they both come out to be the same denominator, then it's a circle. If they're different denominators, it's an ellipse. Here, right here, I have a negative 3x squared and a positive 2y squared. Automatically, I have one's minus and one is plus, so it's a hyperbola. Okay, and then you go ahead and complete the square. Here, I have x squared and y squared. Okay, and it's probably going to be a circle. Okay, but again, after I have whatever number over here, I divide it across. It's the same thing, same denominator. When I'm done, it's a circle. All right, next page. Identifying conic sections. If you're given the equation, you can determine the type of conic section just by considering the following chart. Okay. So this is another way. I've never remembered it this way ever. I think I might have been taught it, but it's way too hard to remember all this. I'd have to remember the order. Ax squared plus bxy plus cx squared plus dx plus ey plus f. I have to put it in that order and then apply the discriminant rule here to these right here. Okay. So you can do that if you want to memorize that. I just showed you how I would identify it much easier from the equation on the last page. So notice it says without writing the equation in standard form, state whether it's one of these or not. Okay. So example, I'm looking right here, 3x squared minus 3y squared, automatic hyperbola. Okay, one's a plus squared, one's a y, and one's minus. Here I have an y squared is max degree on the y's, and here I only have an x. So that would be solved for x. X equals y squared. That's automatically a parabola. Okay, I'm not even looking at the other stuff that they had up top there. So that's what this whole side is just to use what I showed you on the previous page and identify what it is. You'll know why. Okay, that will do it for this one.